Alright, we're going to be using a solution using exponential equation. So when we look at this, it says in the table, write each of the values in the third column, Sally's yogurt, as a power of 4. Well, here we have this is 4 to the 0 power, that'll give us 1. 4 to the first power will give us 4. 4 to the second power is 16, and so on and so forth. So these are all of the powers of 4 that we have for Sally's yogurt here. And then when we look at Lupe's yogurt, well, it says to number 2 and write each of the values in the fourth column as a power of 8. Well, this is going to be 8 to the 0 power, then 8 to the first power is 8, 8 to the second power is 64, 8 to the third is 512, 8 to the fourth, 8 to the fifth, 8 to the sixth. So now we have Lupe's power. And then question number 3, what do you notice when you compare the exponents in the third column and the exponents in the fourth column? Well, if we're looking at these exponents here, so we have 0, 1, 2, 3, 4, 5, and 0, 1, 2, 3, 4, 5. Well, they all are going in numerical order, but when we're comparing them, well, the different columns, alright, well, the power of 4, when we're comparing these, it's always 3 more than this one. So this is 8 to the third plus 3 will give us 6. 8 to the fourth plus 3 will give us 7. So the power of 4 is always 3 more than the power of 8. Or the power of 8 is always 3 less than the power of 4. So the power of 8, so we can say the power of 8 is always 3 less than the power of 4. So the power of 8 is always 3 less than the power of 4. So if you look at it, it goes, if this is 3 and 0, so 4 and 1, it's always going down by 3. So 8 is always 3 less than the 4. Well, then it says, how many bacteria written as a power of 4 would be in Sally's yogurt at 11:30? Well, if we look at our chart at 11:30, well, it only goes up to 11:09, but if you notice this, 11 o'clock is 0, 11:01 is 1, 2, 2, 4 to the second, 11:03 is 4 to the third, 11:04 is 4 to the fourth. So if you notice that pattern, 5 and 5th, 6 and 6, 7 and 7, 8 and 8, 9 and 9, well, it's going to be 11:30. 11:30 will give us 4 to the power of 30. So it will give us 4 to the power of 30. So we can say it's 4 to the power of 30. Well, how many bacteria written as a power of 8 would be in Lupe's yogurt? Well, if we look at what we just said in question number 3, the power of 8 is always 3 less than the power of 4. Well, if we figured out the power of 4 is 30, that means the power of 8 is going to be 30 minus 3, which is 27. And the value of t at 11:30? Well, the value of t is also going to be, if you notice this, 0, 1, 2, 3, 4, is also going to be 30. Now, in lesson 1, this a couple days ago, you were asked when the number of bacteria would be the same in each yogurt. Now we're going to write an exponential equation using our answers so we could solve for the value of t when the number of bacteria will be the same. So what we want to do, this is actually an answers, not 9 and 10, but 4 and 5. So we have our equations close to 4, or for the values, whoops. Alright, so when we look at the power of 4, so what we want to say is this is when they're the same. Well, 4 to the power of t, because t stands for time. So we don't know what the time is. So now if we notice when we go back here, the time is always changing. Alright, so it's always changing. So this is t is 0, t is 1, t is 2, t is 3, t is 4. So it's always changing as t is a different number. So 4 to the t. And then we can also say 8. 8 is always going to be the t, but 8 is always 3 less than it, so it's going to be t minus 3. So the time minus 3. So now we have our two equations here. And when they want to be equal, right, or the same, we want to set our two equations the same. So we have our two equations because t stands for time, and I could say I want it at 11:12. Well, t would be 12, or 11:09. Alright, so t would be 9. So t is our time. We don't know what the time is. We don't know how many 4s we want. And now it says to solve the equation for t. So if we look at this, I have 4 to the t, and I have 8 to the t minus 3. Well, 4 and 8 aren't the same base, so we have to change the base. Well, now what we notice is if we look at this, well, we can break 8 into 2 times 4. Well, we need 4. We can't use the power of 4, so we can break 4 down to 2 times 2, and this to 2 times 2. So we're going to change both bases, not just one, but we're going to change both bases to 2. So this is going to be 2 to the second power, because I have two 2's here, all raised to the power of t. And this is going to be 2 to the 1, 2, 3. This is 2 to the third power to the t minus 3. Now, what we can do here is using the laws of exponents. We can multiply these two values. So I'm going to write this over here. I'll write it in blue. So 2 times t, so this becomes 2 to the 2t power. Now we multiply these values here. So this is going to be 2 to the 3t, and then minus 9. And now we solve this, so same bases, we can drop the bases, and we get 2t equals 3t minus 9. We can subtract 2t, so 0 equals 1t minus 9, add 9, and 9 is equal to t. So now we get t, but the question says what does your value of t represent? Well, t is the time, so the question, it's saying how many bacteria is in each yogurt. So after 9 minutes, both yogurts will have the same amount of bacteria. Both yogurts will have the same amount of bacteria. And now we can actually even check this. We got t is equal to 9. So 9, if we look back to our beginning chart here, if you notice at 11:09, the values are the exact same right here. So we use an equation to solve this, or we wrote out the entire chart to figure out when are they the same. So that, and what we're going to start getting into is actually writing these equations out. We're going to be setting up our exponential equations.